In this video, I am going to solve a problem on 18 electron rule. The question is the number of metal-metal bonds in cobalt 2, Fe2, carbonyl 11 and this PPH twice complex. I have chosen this problem. The reason is this mu4. Many students may be new to this term, that is mu. What is mu? You may be very familiar with this eta. Eta is nothing but the hapticity. How many electrons it donates for the 18 electron count. So that is given by eta, but mu is something different. Mu represents the number of metal atoms attached to the ligand. Mu represents the number of metal atoms to which the ligand has coordinated. For example, when I go for halogen, if there is bridging, then it is mu2. This chlorine has coordinated with two metal atoms. So that is mu2. When I say mu4, it has coordinated with four metal atoms. In this complex, we have four metal atoms, 2 cobalt and 2 iron. Now to predict the number of metal-metal bonds, I go for the electron count. There are 2 cobalt atoms. Each cobalt atom gives 9 electrons. So there will be 18 electrons from cobalt. There are 2 iron atoms. Each gives 8 electrons. So we get 16. There are 11 carbonyl. Each carbonyl gives 2 electrons. So total there will be 22. What about this? What will be the electron given by this ligand? You may be very familiar with triphenylphosphine. Triphenylphosphine can give 2 electrons. But here it is not triphenylphosphine. Look at this. This is not triphenylphosphine. For triphenylphosphine there should be 3. Here phosphorus, 1 phenyl, then here I go for anion. So these 2 anions has formed bond with metal. If it is anionic ligand, then you have to consider one for this and another one for this. In addition to that, we have a lone pair. So total it gives 4 electrons. There are 2 such ligands. So what we get is 8 electrons. If you add, it will be 64 electrons. Since there are 4 metal atoms, 2 cobalt and 2 iron, there should be 72 electrons. But whatever we have got is only 64. The difference is 8 electrons. This 8 electrons divided by 2, we get 4 metal-metal bond. So the metal-metal bond in this complex is 4. That will be something like this. So I have 4 metals at the corners of a square. On the top, I have phenylphosphine ligand. So further, it will be like this. In this, 2 will be covalent bond, 2 will be coordination bond. Similarly, at the bottom also, we will have like this. So if you go for the structure, it will be something like octahedral shape, but the bond lengths will not be same. Even without knowing the structure, you can predict the metal-metal bond. That is, when you go for mu4, the ligand is attached with 4 metals like this. It is possible only when all the 4 metal atoms are in the same plane. So when I go for same plane, I can make only 4 metal-metal bonds.